Here we have a SAT math problem. Okay, let's go to the question. In the xy plane above, points O, P and Q lie on the graph of y equals to 2x square. If the area of triangle OPQ is 54, what is the length of PQ? In the given figure, we have to get the length of this line segment PQ over here. And this line segment PQ connects the 2 points on the parabola P and Q, and also it is perpendicular to the y-axis. Already we know that the y-axis is a vertical line. Since this line segment PQ is perpendicular to y-axis, it's an horizontal line segment. And here the vertex of the parabola is origin. So y-axis is the axis of symmetry. Since y-axis is the axis of symmetry and it's an horizontal line connects 2 points on the parabola, then the axis of symmetry, that is the y-axis, will divide the length of this line segment PQ into 2 equal parts. That is, whatever length we have for this part, the same length we have for this part as well. Okay, once I get the length of this particular part, the same length can be considered for this one. Then we can add the two lengths to get the length of the line segment PQ. So how do you have to get the length of one of these two line segments? Okay, for that, let me consider a value A corresponding to this point Q on the x-axis. Okay, let me draw a dotted line. Okay, now let me consider a value A over here on the x-axis corresponding to the point Q. Then the x-coordinate of the point Q is A. Now to get the y-coordinate of the point Q, what we have to do is we have to plug in this x-coordinate A into the equation of the parabola. Because we have this point Q on the parabola, when I plug in this x-coordinate A for x over here into the equation, I am getting y equals to 2a square. That is the y-coordinate is 2a square. Okay, here I got a point on the parabola that is a comma 2a square. Here the x-coordinate is a and y-coordinate is 2a square. Since we have the value a on the x-axis over here, the length of the line segment over here is a. Then the length of this line segment is also a. Then what is the length of this line segment? Again, the same length we have a over here. Now to get the length of this line segment PQ, we have to add A and A. I am getting 2A as the length of this line segment PQ. Okay, here my aim is to get the value of this constant A. Once I get the value of A, I can multiply it by 2 to get the length of the line segment PQ according to the question. Okay, for that we can consider the y-coordinate at the point Q over here. So this y-coordinate 2a square represents the length of the vertical line segment over here. That is, the length of this vertical line segment is 2a square. Then the length of this vertical line segment is also the same, that is 2a square. Actually, this vertical line segment represents the height of the triangle. In that case, this PQ represents the base of the triangle. Okay, already we have the area for this triangle OPQ over here. Okay, now let me write the stuff over here. Area of triangle OPQ equals to 54, that is given in the question itself. Okay, we know the formula to get area of a triangle, that is base times height divided by 2 equals to 54. Okay, here the base of the triangle is given by this side PQ. Its length is 2a. We can plug in 2a for base over here. And this vertical line segment over here represents the height of the triangle. So the height of the triangle is 2a square. We can plug in 2a square for height over here. Let me plug in divided by 2 equals to 54. Okay, here we can cancel this 2 and 2. So then we get 2 times a times a square is a cube. That is 2a cube equals to 54. Let me divide both sides of this equation by 2. Then this 2 will cancel out. I'm getting a cube on the left side. 54 divided by 2 is 27. Okay, a cube equals to, we can write this 27 as power of 3. That is 3 to the third power. Okay, here two powers are equal with the same exponent. Whenever two powers are equal with the same exponent, what we can do is we can equate the bases. When I equate the bases, I am getting a equals to 3. Actually, we got the length of the line segment PQ over here in the figure, that is 2a. So the length of the line segment PQ equals to 2a. Now we know the value of a, that is 3. We can plug in 3 for a over here. Then I'm getting 2 times 3, that is equal to 6. Therefore, the length of the line segment PQ is 6 units.